So we are going to add a new class. Right click our package name, say Java class, and this is Minesweeper model. So let me remove all these comments. So one new class has been added to our project, Minesweeper model. First let's add the constructor of it. What is constructor? What
Initializer.
Public Minesweeper model. What are the three parameters we are taking in?
Is mine. Rows.
Now this is our board. How many rows? How many columns? How many mines? Rows, columns, mines. And these three properties we also want to keep as class variables. Let me take rows, columns, mines. So once constructor calls, then we'll update rows equal to R. Okay, this should not be in here. How many columns is C? How many mines? M. After the constructor, after these three members are initialized, our model also needs an array of squares. So let's declare that. So it is squares, two-dimensional array of square, and we call that let's call that squares. But square is not a class that we have defined yet. We have to define that class. So if I click this, it gives four options. First, create class in package Minesweeper. That means if I click this option, it will create another file, square.java. It will add a class, but we don't want that. We want internal class. Second option is create class square in in.being0.games. That means class in this class. This is second. Here the name is given as our class name, not the package. Previously it's in.being0.games.this. Here it is creating in our class, inner class. So if we click this, we see in the end of our class a new class has been added.
It's not in our class.
It is inner class, this one.
We are creating it inside this something.
Yeah, so square class got added within existing class, but it adds a static here. We don't want it to be static, so let's remove that. Clear? So we have added a square class. Now let's first put the elements of square. In this, each square is identified by its location in the board. Int row, int column, and we also take a variable is mine. Initially when we are putting mines, then we will need this third member also, because first when we are putting random mines, we'll say these 9 buttons are mine, rest are not mine. So this constructor will be used. So properties of square, we talked on this slide. Boolean is mine. Next is open. Is open. If it is false, it is closed. Next, Boolean is flagged. Int neighbor count. For this particular square, what is the neighbor count? These 4 properties we want to keep with every square. So when we initialize, okay, rows and column, row number and column number of this square also we want to keep track. Int row, int column, right? So when the constructor is called, what we do? Row is equal to R, column is equal to C, is mine equal to is mine. Now there is a problem if I write that. It will say you are assigning value to the same variable. So this is there in the class. So this operator if we use, that is saying the left side is member of current object, right side is what is coming as a parameter. So we have initialized these 3, but we have other members also. So other members, this dot neighbor count, what should be the default we should put?
0.
Initially let's put 0. This dot is open, default value
False.
this dot One is remaining. Is flagged by default.
False.
Default value false. So with this our square class is complete.
For ismine also we can take false no sir.
Hmm?
For ismine also we can take it as false no sir.
Now is mine, because we will be randomly putting mines, and that is the time when we will construct square. So when we are constructing square in our board, there is a two-dimensional array. One by one we will be calling new square. So wherever it is mine, we will pass true, otherwise false, because this is a variable value that we have to control. For others, it is fixed. If we put it false by default, then using some other logic we'll have to make it true. That also we could have done. So now our model is ready. Square is not yet initialized. So we first want to create this array in constructor itself. Squares equals new of,
Square.
So that is an array, no sir?
yeah, that is a two-dimensional array. So this is how we allocate two-dimensional array. Rows, calls. Yesterday we created buttons like this in UI.
Can you place the statement in the constructor sir?
Yeah. So all the members of our Minesweeper model should be initialized within constructor, and this is also a member. For square, we are initializing here, right?
But its constructor parameters are not given, no sir. Mine is mine.
No, that we will give later on. Right now we are just saying create an array of pointers initially which will be null. This is just create space for our array. Each and every square we have not assigned. So right now square of ij will be null, right? Because all the objects that we have, they are stored in heap. So right now we have just taken space to store these many pointers. After we have got the square, we should randomly put mines, because that is what our goal is. Rows, columns, mines. Mines we have not honored till now. So we will say insert mines as a separate file. And after mines are inserted, update neighbor count. Update neighbor mines count. So these two functions we need. So another feature is when you call a function first, this will add signature automatically. We click here and says create method in your class. Class name it is giving. So we click this. So method is added. Initially it is saying unsupported operation. That means it is not implemented. The way we did it in C was by putting asserts, not implemented method. So let me delete this line. Now this is a function that you have already done. How we wrote that function? Using random number generator. So in Java there is a random class R equals new random. This is in java.util. So it will say, I don't know what it is. When you click, there are three options that come. First is add import. Second, create another class named random. If we click the second option, it will add a new Java file to our project, but we don't want that. Third is create class random in internal class. Second option is create a class in your project. Third is internal, but we want to pick first option. So random we have obtained. So next goal is how many mines we want to insert?
And mines. This dot mines.
In class there is mines member. So this dot mines. So we'll have to write a loop for or while. That time we did using while. So let's proceed with while. While I is less than mines. If there is no confusion with command with the parameters of the function and our class member, then we don't need this. If you write this or not doesn't matter here. But if mines was an input parameter to this function, then you have to differentiate. But this you can write, it will work fine. One and the same thing. Here it is redundant, so I'm removing. So while I is less than mines, what we do? We want
to check.
random row and random column given to us first. So let's generate R and C randomly. R and D dot next int, and then we do modulo rows we used to do, so that our number is within rows. So in Java, that is already made as a function and given to us. So in function you pass rows, it will make sure the value returned to you is between 0 and row minus 1 inclusive. So ideally we could have done modulo way also, but this function call gives the same result. So one random row, then next int calls. With this we get a random row and random column. After we got that, what we have to do? First we have to check whether it is already there or not. So way to check is, if squares we gave the name, right? If squares of I and J are C now, R and C, if it is null, initially we have not constructed square. If that is null, what we do? Square of R C, we say equals new of square of R C true. Should we say true here?
Yes.
We are inserting mines now, so it should be true. Okay, it should be squares. So we are saying insert one mine, and I plus plus we should be doing here, not outside, because otherwise we will miss putting some mines. So with this, what has happened, in complete board only few squares have been created, rest of them are still null. So we have to initialize them also. So let's put there, we will initialize using new square RC false, because rest of them are false. So for int I, okay, I we have declared above, we can use that directly. Let me declare a J also. For I0, I less than rows, I plus plus.
Sir, any of this step you are writing, new square, we can write it for all nodes, and if we check it doesn't have any mine, then we'll insert.
Yeah, that's what we will do.
We are doing it twice now, sir, actually.
We are doing it? No, first loop was only for mines. It was not two loops.
We'll put that statement squares of I, we'll do squares of ij, sir.
Mhm.
And at every square we'll put null, sir. And if it
Here
is,
there is no J in this loop.
we'll put it outside, sir, that statement.
This statement,
That is a common statement, sir, anyhow.
yeah,
So we'll make all of them false first.
okay. So he's saying let's make all of them first false before this loop, before putting mines, and then later on you see, you check if it is true or not. One and the same thing, it's just that this loop comes after or before. But both the loops you need to have. So that is also there, that option. If square of R ij is not equal to null, or if it equal to null, then
Continue.
no. If it is null, then we want to create square I j equals new square I j and false. Done. With this, what will happen? Our board is ready with all the mines. So we want to print it and see. We want to have some logging also. We want to see what is the board that is getting created. So within the same loop, I'll put some logs. I want to print board in such a way, wherever there is a mine, print star, otherwise print dash, so that on output we can see. So in second loop, can we say system dot out dot print? I'm not using println because entire row I want to print once. Dash will be printed when?
Minus not there.
If squares I j dot is mine. Now we can access this property. If it is mine, put a star, else put a dash, and after this line is over, new line, which is system dot out dot print ln. So just print ln will give a new line. With this we are making sure the board is printed. But now we have not called this constructor from UI. Ideally when new game is created, UI should draw its button and it should call Minesweeper model. You initialize the board, then we'll allow user to play. Okay. Before we connect this to UI, let's implement the other function, update neighbor count. Click here. So it adds a new line, new function it's created here. Delete. So how do we update neighbor mines count? We have to go to each and every square and then calculate it neighboring mines. So for loop, two for loops, I less than rows, I plus plus, for int j,
We'll call another function from here.
yeah, we'll call another function that will calculate neighbors for each square. Then we say squares. Now because all squares are constructed, they are not null, we can access that. Dot neighbor count equals get neighbor mines count, and to that we'll have to tell ij, because that's how we can calculate the neighbors, right? So again it gives us option create a method. We click that. Just below it a method is created. Now how should we write this logic? For any given I and j, neighbors are from previous row, previous column to next row, next column. So for, let me take I and j are coming as input, so let me take a and b. For a minus 1, a less than equal to 1, a plus plus. For int b equals minus 1, b less than equals 1, b plus plus.
If not equal.
Yeah, so we have to take I plus a and j plus b. So let's take that into another variable. R a plus I, just for clarity, b plus j. Yeah,
So
now the
that
check.
will create every time R and C.
Yeah, that we can declare outside. Int rc, and we need to count also. So let's declare int count initialize with 0. So with this R and C every time will not be created. Yeah. So now before processing this neighbor, we want to check whether this neighbor is valid or not, so that we are not going outside the bound. So what is the check? If R
Is greater than
greater than 0,
0.
Greater than
Less than or equal to 0.
Less than 0.
Greater than or equal
what
to
is the valid value?
Greater than or equal to
0 to
Rows
last
minus
one.
Is this correct?
Greater than
Greater than or equal
Greater than equal to 0. Then less than equal to rows also.
No, sir.
Less than
Less
or
than
less than
Rows. And same for column. C is greater than equal to 0. Can we do count plus plus directly?
R not equal to
Not equal to
rows
I,
and
R not equal to I, C not equal to
R should not be equal to I and
I
J.
and
I and
Okay.
J.
R and J should not be equal. So that we can put here. If R equals I and J equals sorry. If R equals I and C equals J, then continue. Correct? But is this check correct now? What is it that we are counting? Mines we are counting. But here it will count all the neighbors.
And if that is mine is true or not.
And
This
for square of
Squares
squares
of
of
R, C.
R C dot is mine. If it is mine only, then increment count. So after this is done and we come out, we should return count. So this completes our get neighbor count also. And where did we call it? here. In Java, another benefit is doesn't matter where you define your function, up or below, no forward declaration needed. So after we are getting neighbor count, let's print this also. For debugging, it will help us. So system.out.print squares I j dot neighbor count. So this is done in with print, and then once a row is done, println, a new line is printed. Perfect.
So if it is a mine, we'll not call the function.
If it is a mine,
We'll not call neighbor count function.
okay, that's a valid point. If it is a mine, why should we call? But even if we call, whatever is updated, we'll never access it from mine.
But neighbor count we're updating no sir. Like
Yeah,
so.
so let it be for now. Because even if a square is a mine, it has a neighbor count property. Something should be put. But we'll make sure,
Zero starting no sir.
yeah,
We're changing that now.
correct, we are changing. Even if we leave that, that is perfectly fine. Because whenever we are processing in UI or in our model, we'll first check for if it is a mine or not, and then we'll go to neighbor count. So neighbor count we will never access for a mine. We'll ensure that when we are accessing. But your point is valid. We don't need to call for mines. We could have done that, but for now, let's keep the code simple. Otherwise, there will be so many conditions. So with this, our neighboring mine count also has come, and now it's ready to be linked with UI. Just that it will create the board. Right now, interactions functions we have not written, which were click, toggle flag, all those functions we have not yet written. So let's go to GUI and let's add a member at a class level, and we call it Minesweeper model. Minesweeper model is a class, and object of that we are keeping here. Construction we will do in constructor, because we should construct based on the rows and columns. So wherever we are calling new game, that time we actually know how many rows and how many columns are there. So let's construct a model, new Minesweeper model, rows, columns, mines. With this, whenever we start a new game, it will call the model, it will say create the game and keep with you. Next interaction I'll tell you. So if we run this now, we should see our logs that we have added. Right now we have added logging, system.out.println. At least output, some output we should see. Here also, let me separate that with a space, each member. So let us run it. Here we don't need to ask it will compile or not, because immediately it keeps compiling and telling us. So save and run. So when we run it, what we are seeing in output is there is a mine placed in third row. Okay, let me increase the size. So third row has a mine. This is a star. Fourth row has a mine. So first row and second row, they don't have a mine. So first row is completely zero for neighbor count. Second row, these three elements will not have zero neighbors because they have one mine below. So these three will have one. Next, okay, these three are having three. Right now, Sadhana was mentioning that even for mines we are updating neighbor count. Right? This is a mine. For this also we are saying there are two neighboring mines for you, but we will not use that. So this function works fine, looks like working fine, right? So now let's stop this, let's terminate this run and proceed with writing which function? Linking we have done. A model is sitting in GUI now. So for any click, GUI will call model. But model does not have all the functions implemented. Toggle it does not have. Click it does not have. So all those functions that we had listed, let's see board functions. The first function was, okay, toggle and click are more important for us. So let's implement toggle and click. So toggle, what will it take? toggle flag for which square? ij. It needs ij. And what will it return?
True or false.
Okay.
It can enter state also. I mean,
For getting flag state, we'll write another function.
is flag also it can return.
Is flagged. So let's write that function first. Public, we are declaring public because other class is using it. Public is flagged. Okay, public boolean is flagged. We are giving it an I and j, and it should tell us whether that is flagged or not. We can directly return squares I j dot is flagged value. If it is marked,
Check it is open or not, no sir.
hmm?
If you check it, the box is open.
This is flagged. This is just query, but in toggle flag we will check that. Yeah.
How did we create the links between the two different classes?
Okay. In constructor of UI, we constructed our model, and this model is made a member of our GUI class. Now our UI contains one model object. So when the GUI is launching, it will tell to the model, you create your game, put your mines and keep with you. Next time I'll tell you what to do.
So first GUI will be called and then it leads to the program.
Yes. First GUI will be called, GUI's constructor will be called. In GUI constructor we are calling new game. In new game we are instantiating our model. Right? Because UI wants to use our model. So we added this. Now we are adding toggle flag. And let's make it void because state can be checked with previous function. So when we are saying toggle flag, Sadhana says first thing we have to check is open or not. If it is open, then is toggle flag doesn't make sense. So we say if squares of I j
Dot is open.
is open,
Is equal to true.
that is true only. If that is open, then don't do anything.
Don't do anything.
Or if we say if not open,
Toggle.
then do this. We will call squares I j dot is flagged equals to not of
is flag. Is
squares of I j is flagged. Is flagged is a bool variable. We just did not of that. So this will toggle flag. Right? So next function we want to implement click. Public void click int I int j. Now this is interesting function to write. Now if a button is open and UI says click that, what should we do? Nothing should be done. If squares of I j dot is open, then nothing should happen. So again we'll do not and we'll start writing logic in that case only. If it is not open, then only we want to process it. Then that UI will differentiate because this model does not deal with mouse. UI will deal with mouse, and based on right click it will call toggle flag. If it is left click it will call click method. Right? So open we have checked. Next.
So we should know whether it is a flag. I mean, we should inserting a flag or is it?
Yeah. So now that depends. If it is flagged and user clicks, what do we want to do? Should we allow him to open it or
End the
not?
game. End the game is right there.
Hmm?
Right there, end the game. If it is a mine.
No, sir. If this is trying to insert flag,
Mm-hmm.
then we should insert it.
Then it will not come to click. Then it will go to toggle flag.
Okay.
Sir, it will check if neighbor counter.
Sir, after inserting flag, can he click that? Can't click now, sir.
No, that is what we were talking about. If he has put a flag and he wants to click, we will allow him to click. If there is a mine, we will end his game. So let's allow him for now. So we are not adding a check for his flag. So
Check it is a minor
If it
or
is
not.
a
it is a
mine,
minor,
then
that's
that
yeah.
is
Now we have to check if it is a mine or not. If it is a mine, what happens?
And
the game.
End the game.
Game over. So let's add another member to our model. Int game state. And the values that we can give to that will be, let's say, public static int over, let's give value 0. Public static int in progress, we give value 1. Int, then won, we give value 2. So based on the state, we'll return one of these three values, or we'll set these three values in game state. So now let's come to click. What are we saying? If
Squares of ij.
let's every time we are going to write this, let's take this in a variable current square. Squares of ij we are taking in one variable, so that every time we can write cs dot is open. Cs dot is mine. So what we are saying, if it is mine, what happened?
Squares.
Is spelling wrong?
Squares class.
Squares is an array. Square of ij should be one element of the array. Square, maybe, let me copy that. Square of pasted code refers to not imported elements. It should work. Is okay, I don't know where is the mistake.
They both are not a linked, no sir.
Now square is an internal array. Oh, it's an internal class
Of the previous other file.
of the model. No, this file only. So I'm not sure whether we can use it. So let's keep it for now. Let's stick to using squares ij. Squares of I, j, and proceed. Copy paste will do. If this dot, okay, now even for this it is not coming. How it is able to access is open but not this. I don't know. So is mine is not there. Did we add that to our squares class? Where is square class?
Yes, sir.
Yes, sir.
Is mine is there. That is strange. Dot. None of the members it is accessing now. Let me just stop here and compile it. Let's run it till this point. Fine. Squares of I, j dot. Now it came. Okay, so let's take then, let's try the same thing that we were doing. Cs is equal to squares of I, j. Can we use cs directly? I think yes. Now if cs dot is mine, what we say? Game state is equal to, we have defined
Over.
static.
Over.
We can directly use that over. Or we can use class name dot over, because static members can be accessed using class. And after we say that, we have to return.
Game state.
Now here we are not returning, we just set the game state. We'll leave on UI to try that, or we can return, that will be better. Yeah, so let's return game state. Or then why to assign it? Then we don't need the class level variable. We can return over directly, right? If we are returning, so let's not add a
Game state.
game state, because Y model will keep track of this. Otherwise, if it is not a mine,
Continue in progress.
Show the name.
show the neighbor count. That means, okay, model will not show the neighbor count, the other person will show. So here we have to check if it is not a mine, then we have to open it. Right now everything is closed. So we can say cs dot is open, true. Clear? So we opened it. Now there is one trick in the game. If you click on a button which is not having any neighboring mines, then what happens? All its neighbors are opened automatically.
Yes, sir.
So that is the logic. That means recursion involved. So if current square's neighbor count is 0, then for all its neighbors call recursively. Just that for mine neighbors that are mines, don't do it for them. But for all others, do it. So if CS dot neighbor count is 0, we want to put some logic. What is that logic? We have to calculate it neighbors. How do we find neighbors? 2 for loops. Int I is equal to, okay, ij are there. A is equal to -1. A less than equal to 1. A plus plus. For B -1. I think this also we should have done in our exercises. Click B plus plus. Then what we do?
Call the recursive.
Yeah. And we'll call only for valid neighbors. So let me calculate R and C here. That way it becomes easy. Int, okay, Krishna will say int should be declared outside, which is valid. So R should be A plus I, C should be B plus J. Now, if R is greater than equal to 0 and R
Less than rows. C greater than
and C less than calls. One more condition we talked about.
squares of 5
Squares
is
of-
mine. It's not mine.
RC
Squares of R, C,
Dot is mine.
it should not be true. Because for mine we don't want to make this mistake. Then what we do? Click.
Click. Open that one.
You want to say?
But it will open every square which is
It
not
will
a
open
mine square.
only its neighbors.
It will recursively call.
Correct. If neighbor has a neighbor count 1, then that will not call recursion. Only mines with 0 neighboring, only squares with 0 neighboring mines, for them it will be called recursive.
Then it will open only all the others except the mine and its surroundings. That's all.
Yeah.
We can easily win the game now.
No, it will not do that. If there is a position which has its neighbors and none of them is having 0 neighbor count, so it will stop there. It will not spread beyond that. Right? So only if link that you are clicking, if it has 0 neighbor count, only his neighbors are opened plus all the neighbors of 0 neighboring count again. That's why we need recursion. We want it to spread.
There is a I am saying that there is a possibility if we go like that, the mines will be separated somehow.
Okay.
Then we can get all
Yeah,
the mines
chances
all-
are entire board is exposed.
Yes.
We'll see once we try this. So this is the logic. Is that fine?
Yes, sir.
Before that, should we also check if it is already open or not?
In click will do that.
In click, that check is already there. If we are calling it for a block which is already open,
Then we
then that will return. But for flags, if it is flagged,
don't open.
we should not go. Right?
And
In click only we can check no sir if it's
and the squares of
Yes.
R.
So here itself, okay, somebody said this already for flagged. Okay. So if it is flagged also, what we should do? We should not process click. Let's see. If CS dot is flagged, again same problem. Not Minesweeper, yeah. If CS dot is flagged is not coming, should I compile again and sometimes what is happening, IntelliSense doesn't work. If CS dot is flagged, return. Yeah, we have to return integer value. We say in progress. And in all the else part, when it comes down, that means we have just opened this. Here also we should return in progress. For now we are not returning one anywhere, which is fine. We'll add that logic later. So in progress is something that will return to UI. With this, our model is, lots of pieces of model are ready. Now we are ready to process the click, and after the click we are ready to tell to UI that if game is over or game is in progress. These two things we can tell back to UI. Now we have to go to UI to process click event. Ready for it? Huh? Not ready?
Sir, one small doubt, sir.
Yeah.
We created an object for model, sir. How did we do that? I didn't get it, sir.
Okay, so we'll see that. So model is a separate class. Separate class. So we go to UI. Where do we need model in UI? In UI, do we need a model?
Yes, sir.
Because
On the panel.
UI has to talk about to model, not in panel. Let's say in UI class we add a member model, right? So what we have done in UI, we have added a model member. So when should this model be created is a question. When should we call new on this model? When we are creating a game, because model takes rows, columns and mines, and that is determined in a new game. So in UI we went, we just added a class level member, Minesweeper model. That is there in this. Where are we instantiating it is inside game. When panels were created, when buttons were added, that time we just made a call to models constructor. So here created. Now all the actions will use this model because this is class level member. When you click a button, a method will be called and that will take model.click.
Yes.
Yeah.
Sir, how it will open, sir?
How it will open?
Open and show something. Where we are clicking that, sir?
That is there in the square. So now when you click a button on UI, it will call model.click. UI will have a function which will get called when you click. Model.click will be called and that will return us the game state.
We have to add that, no, sir. in
Yeah, we
UI.
have to add that. We have not yet added that logic. So mouse click handler we have not yet added. That's why people are saying enough for today. Once we add that mouse handler, one function we will create that will be called on click.
Sir, before making ease open true, we should open the block, no, sir.
How will we open the block?
I'm asking.
In model.
No, sir. In click.
Mhm.
అక్కడ mostly
So in model, open means nothing, just setting these open property true. At UI it means if it is open, give me the neighbor count, I'll show according to that the image.
That was, sir, before setting true, we should open the block, no, sir. We are not performing that function.
How should we open the block?
I'm asking that.
Okay, a button's open is just setting it to true, nothing else. A square open is,
In UI, how will you know, sir?
yeah, that's what I'm saying. UI will call open, this will set it true. UI got game is in progress. Now UI will check the ij that I sent, is that open now?
It will come true, no, sir.
That will come true. It says okay, if it is open, tell me the neighbor count of that.
But
It
in
will call.
output we did not open it, no, sir. We are not sure.
Yeah, so UI before coming to that, UI is doing this. Now UI will go and check, say, give me the neighbor count of this. From backend model will tell neighbor count of this is 1. Because it is 1, UI will open a new image and say buttons ij dot set icon 1.gif. Then it will appear.
Sir, first it has to set and then it has to check if it's open, no, sir.
Yeah,
Otherwise, always it will be open, no, sir.
correct. So that's why when UI click received, UI calls model.click and model sets it. After that, model returns back the game is in progress. Now UI knows because game is in progress, that means it was not a mine. Next thing that I have to do is I have to ask for neighbor account to show the right icon. Now because it is opened.
But the previous ones, the open ones are also already set as open only, no, sir, in that phase. Initially it has to, the UI before displaying it has to check if it is closed, no, sir. Then only it has to display
Initially when UI launched, everything was closed. Now when you did one click, for that only you will check and open it. Or if it has never gone to 0, then means you have to do for entire board. Stop.